Hi, I'm Paul Brebner, the open source technology evangelist at Instaclustr. Today I'm going to demonstrate creating a Kafka cluster on the Instaclustr Console. So one way of getting a Kafka cluster is to download the software and do it all yourself. Mind you, you also need some hardware to run it on. So one of my colleagues, Cassian, went down this route and built a Kafka cluster from scratch as a learning experience. They built a portable model demo cluster that they could show off at conferences. Here it is. This was fun, but lots of work and size limited, of course. It was portable, it fits in a box, but it's quite hard to scale it any bigger. An easier way of creating a Kafka cluster is using Instaclustr's managed Kafka service. So here's our website, instaclustr.com. You can sign up for a 30-day free trial with no obligation and no credit card required, and then try us out. And then you can log into the console. So the free trial button takes you to a page where you can create an account, and then you can log in. And once you log in, here's what the console looks like. What do we need to do? Well, let's create a cluster. Now, what do we need for Kafka in particular? Well, for Kafka, you need a cluster, brokers, topics, and partitions. So the console takes us to the first thing, which is creating a new cluster. And the first thing it turns out that we need is a name. So a good name for a Kafka cluster, I think, is Franz. Oops. Let's lock off Franz. Now, the next thing we'll notice here is the SLA tier. We're going to stick with non-production. For developer size nodes, non-production is the correct choice. The only other option is production SLA tier, and that's for production sized nodes. So what technology do we want? Well, we want an Apache Kafka cluster. So you select the correct technology under the application section. Apache Kafka is a distributed pub/sub streaming system. We provide the open source version as a managed service. It also optionally works with Apache Kafka Connect, which is that technology there. Kafka Connect is great for integrating heterogeneous source sync systems via the Kafka cluster, but at the moment we'll just stick with the basic Apache Kafka. The next option is the provider selection. So this is the cloud provider that we want to provision some infrastructure on and run Kafka on, and we'll use AWS in this instance. Yeah, that's all that's of interest on the first window. Let's click next, and that takes us to the second window. This is the Kafka setup window. This is where we have to specify a few things that are fairly specific to the Kafka technology. First option is the version. We'll stick with the latest one. We normally provide the latest and a few previous versions. The latest one is an excellent choice. Kafka options. Add your current IP to the firewall allowed addresses. This is quite good for testing. It allows your machine that you're currently running on. In this case, I'm running doing demo on a laptop. This allows me to connect to the cluster any trouble later on. Use KRaft mode. We'll leave that selected by default. KRaft is the latest version of the Kafka metadata and cluster management technology, and it replaces Zookeeper, so that's a good choice. Zookeeper will not be supported for much longer. The next option is to use dedicated KRaft controller nodes. We won't click that. We're just building sort of a developer demo cluster at the moment. In production, you would want to do that. It's quite useful to have KRaft running on its own separate nodes. So I mentioned for Kafka, you need a cluster. You also need topics for Kafka. You can manually create them or allow Kafka itself to automatically create them when you try and write a record to a topic that doesn't yet exist. So let's enable topic auto create. That's ticked by default, and topic deletion. That's probably not a good idea for a production cluster, but we'll leave that turned on for the time being. But what are topics? Well, being a pub/sub system, Kafka producers and consumers don't know about each other. They just produce or consume records to intermediate topics, which brings us to the next topic, which is partitions. So topics have one or more partitions which determine the concurrency. Basically, the more partitions, the higher concurrency they have. The number of partitions limits the consumer concurrency. You can only have as many consumers as partitions. So more is useful if you've got slow consumers, for example. A good default number is around the number of cores in your cluster, or you can potentially have a lot more these days with the K-raft mode. But you can increase the number of partitions for a topic later on, so don't worry too much at this stage. So we'll leave that at 3. Replication factor, that's the next setting. 3 is a good number for that. Replication factor determines how many copies of the data the cluster has. An RF of 3 is good for production and stores a copy of the data on 3 different brokers. Listener setup. Listeners are a slightly obscure Kafka concept. In fact, one that I hadn't come across until preparing for this demo. Essentially, it's just the way that Kafka allows for client authentication and encryption. So these are some options we provide. The default is SASL plain text, and we'll just stick with that for this demo for the time being. Enterprise add-ons, there's a whole bunch of other technologies that we offer as well, which are complementary to Kafka. These do cost a bit more, so think about whether you need them or not. You can add them later on. Carapace is the open source schema registry that we offer, and also the open source REST proxy that we offer, which allows you to connect to Kafka via REST clients. We also offer something really cool and new, which has only just become available, tiered storage that allows you to have a lot longer data retention for less money by using cloud native storage. The bundled use only, we won't tick that. That's only used if this Kafka cluster will be used as part of one of our other combined services that use Kafka, for example, Cadence, not directly. Okay, that's all we want to do on this window. Let's click next and go to the next one. This is the data center options window. So because we're deploying Kafka into a cloud, AWS in this case, we have to now select some cloud infrastructure. In this case, some AWS infrastructure. The first choice is, where do we actually want the cluster to be provisioned and running? There are potentially lots of locations. The location determines price and potentially latency, depending on where your customers and the application are. I wrote a blog a few years ago around the world in approximately 8 data centers, which explores the impact of AWS data center location on application latency. For Kafka, you definitely want your Kafka clients to be running as close to the data center where the Kafka cluster is as possible. So I'm just going to pick Sydney here because I live in Canberra in Australia. Now we come to node selection. So what's a node? That's a slightly odd thing, given that I've been talking about Kafka brokers. So Kafka uses the terminology brokers for each server in a cluster. This is because it's the default message broker terminology, but we actually call them nodes across all of our technologies for consistency. So Kafka is a horizontally scalable cluster technology. The more nodes you have, the more resources the cluster has. And for Kafka, this includes CPU, memory, and storage, and I guess network as well, giving higher throughputs, lower latencies, and longer data retention. 3 is the minimum number of nodes we offer to ensure high availability. If one of the brokers fails, the cluster will still keep working and recover the lost broker and data eventually. So we'll stick with number of nodes 3. So the final choice we have in terms of infrastructure is the node size. We offer development and production node sizes. The main difference is CPU type, number of cores, RAM, and the local storage type and size. For this demo, I'm just going with the smallest demo node size that we offer. You can increase the cluster size vertically with some bigger instance types, or horizontally with more brokers once the cluster has been created. And when you're deciding on an initial cluster size, it's normally better to start with the smallest instance sizes, but maybe more of them, as it's trivial to increase the cluster size vertically later on. The price per month per node, you'll see here is displayed. That's quite useful as well. We'll click on next, take us to the final window. And here we see a summary of what we've requested and the total price per month down the bottom here. You can go back at this point and check or change anything you like, or you can accept the terms of service and click on create cluster and then wait for a while. And I'll come back in a while once the cluster is provisioned and is running successfully. So after creating a Kafka cluster on the Instaclustr Console, let's check if we got what we ordered or not. Apparently we've got a cluster here called Friends, which is what I named it, and it looks like it's Kafka. Let's click on it to find out more. Okay, let's have a look at the details tab first of all. This is where we can find out the name again. Yep, it's Friends. It's a Kafka cluster, and the provisioning status is running. It has actually started up and is working correctly. That's good. That means we can have a look at what's going on and potentially start using it. If you look further down on this window, you can see the list of brokers or nodes, as we call them. You can find out what size instances they are, where they are, and the public IP and the private IP addresses, and the provisioning status and the roles. So these are all Kafka brokers, but they also have the KRaft controller running because we're just running a small demo cluster. We didn't want them as dedicated servers. So that all looks good to me. Let's have a look in a bit more detail what's actually going on those brokers. If we click on the monitoring tab now, this is the default summary metrics. Now, we've got very high level metrics in this view, mainly just the basic hardware. So the CPU usage for each of the three brokers is very, very low. It's only like 2%. We haven't used any disk yet because it's a brand new cluster. We haven't been sending any records into the Kafka cluster, so there's no storage overhead yet. There's a couple of Kafka specific metrics that we see here. The broker bytes in and out, so that's some basic throughput information. And surprisingly, these are non-zero. So that's interesting, what's going on at this point. Let's have a look at some other metrics. If you click on up here, we can select some other metrics. And if you look down the list here, you'll see under Kafka broker synthetic transactions. So let's click on that and see what's happening. So synthetic transactions are something that we provide to ensure that the cluster isn't overloaded. So for production clusters, we actually monitor the latency, and we'll do something to alert you if there's an increase in the latency of these synthetic transactions. For a developer cluster like this, it's just for information purposes. So we provide the consumer average and maximum latency, number of records, and also the producer latency average and maximum as well. So as you can see, they're actually looking pretty good at the moment. Very low latency average values there, around about 6 milliseconds for the consumer, and yeah, between 4 and 6 for the producer. So this cluster does not have any load on it at the moment. So the synthetic transactions are all pretty fast. So everything's pretty good there. What else can I show you? Let's have a look at something slightly more detailed now. Let's go to the partition metrics, which is under Kafka broker again. Let's click on the partition metrics and see what we can see. Now these show things like the number of controllers, the leader count, and the most interesting one that I want to show at the moment is the partition count. Now this is actually between 53 Oh, so it is 53 at the moment. So that's perhaps slightly higher than I would have expected. The synthetic transactions that we use only have, I think, 3 petitions each. So that should only be a petition count of 6 at the most. So what's going on here? Well, it's because of the new kraft node in Kafka. Essentially, Kafka now uses kraft to manage the metadata and cluster control of the cluster inside Kafka itself. So that's actually using some internal topics and therefore some petitions as well. Right, well, let's see how you would actually use this cluster. Let's go down to the connection info tab. There it is. Now, the connection info tab explains how to connect to the cluster with some examples. So at the top, it displays the broker IPs and the username and password further down here, which is critical for connecting to the cluster. Something to watch out for, we only retain the username and password on the console for a maximum of 5 days, so that information will vanish. And then you need to have either created some other users or kept a record yourself of what that information is. Under the example section here, we've got examples for producer and consumer and topic management. Let's have a look at the producer consumer examples for a start. So there's lots of different clients that you can use to connect to a Kafka cluster. The Kafka CLI comes with the Kafka distribution itself. Or you can write Java or Python or other programming language clients as well. Let's have a look at the CLI producer example. So to run this, you would download and unzip a copy of Kafka yourself, and you would create a configuration file. Now here's an example configuration file for this cluster. So it's specific for this cluster. It's got information about the SASL protocol mechanism and the username and password as well. And then it's very simple to start sending messages to the Kafka cluster by using the console producer. You have to supply one of the public IP addresses with the port number 1992, the name of the topic that you want to write to, and the name of the file that contains the Kafka properties. And the Kafka producer is very similar as well. You just specify the same information and start consuming messages from the Kafka cluster. So currently, as I said, there's not much load on the cluster. It's not actually doing anything. So let's explore a scenario where the load is expected to increase or actually is increasing, and we need to resize the cluster. So one easy way to put more load on the cluster is to increase the number of partitions. Replication uses more cluster resources with increasing numbers of partitions. So let's go to the topic management example here under Kafka CLI. So this shows some of the CLI commands to create a Kafka topic, to change the configuration of the topic, to list topics and delete the topic as well. So I've already set this up myself. What I'm going to do is create a test topic with 10,000 partitions. So let's create some more partitions on the cluster and see what happens to the CPU load. Right, so as you can see from the metrics console here, the CPU has gone up substantially since I created a topic with 10,000 partitions. And looking at the partition metrics as well, they've all, or the leader count and the partition count naturally have jumped as well. So what I'm going to do is actually just leave this cluster for a while until everything has stabilized. Okay, so I've come back after a few minutes. The CPU has dropped from a bit of a spike around about 80 to 90% CPU and back to a more manageable 30 to 50% CPU utilization. The command to create the topic with 10,000 petitions appears to have succeeded. There are now 10,000 petitions shown on the petition count graph. And yep, so that's all good. I thought I'd also just show you, while I'm here, the application logs tab. So under this tab, you can actually view the Kafka logs on each of the brokers. That's quite useful. And you can also resize the cluster as well. So one way of doing that is under the Add Nodes tab. This will allow you to request to add further brokers to the cluster. This is a request-based mechanism. We actually have people behind the scenes who will check the cluster health and make sure that that horizontal scaling action will succeed successfully. The other option, though, is you can resize your cluster vertically. And this is the screen that allows you to do that. So one of the configuration choices is how many concurrent resizes. With a cluster of only 3 brokers, there is only a choice of 1. With larger clusters, you can have a larger number of concurrent resizes if you wish. So this screen shows us what the current node size is. We've got 2 CPU cores, and in order to increase the total CPU resources for the cluster, we really need to increase the node sizes to something with at least 4. So I'm just going to increase them to the smallest 4-core production node size that we have. That should work. It's telling us that there's going to be a price increase. That's not unexpected. And I'll click on the resize data center button and keep my fingers crossed that the cluster is in a state of health, which it isn't, unfortunately. Great, so the resize data center request worked okay. And this is the status page, and we'll come back in a few minutes to see what's happened. So we requested a cluster resize a while ago, and it is now resized to R6G extra large, which are 4-core production sized instances, and they're all in the running state, which is good. So we've succeeded in increasing the vertical size of the cluster. Let's just have a brief look at the monitoring and see what the impact is. The first thing, I'll just go back to an hour period here. First thing we notice is the CPU was around 40% when we decided to resize, and it's now back to a more usable amount below about 20%, so between 15 and 20%. So you will notice that during the resize, because we only had a very small sort of demo development cluster with 3 nodes, during the resize, it has to basically shut down a node or a broker at a time and replace it with a bigger one. And the impact of that is that the CPU usage on the remaining 2 brokers actually does go up during that period of time. So you want to make sure you do this resize operation well before the load on the cluster will increase, or have a larger cluster at that point. What else? Petition count is still the same. We created a 10,000 petition topic that has succeeded. The active controllers flip-flopped around a bit during the resize operation, not surprisingly, because some of the brokers went away. Producer message latency, that was one of the reasons we decided to resize. The SLA synthetic transaction had a fairly high latency when we decided to resize, around 100 milliseconds. That's dropped back now to a more normal 50 millisecond average. So that's all good. The cluster is bigger, and better, and you can now hopefully use it and put a load through it. So that's all from me for the time being. Thanks for watching. Have fun with our Instaclustr managed Kafka and the console.